All right, so this is part of the 116 learning check, and we're looking at piecewise functions here. So we do have a piecewise function defined as negative x minus 1 for x less than negative 1 and x plus 1 if x is greater or equal to negative 1. The first thing is talking about the domain of the function. Domain is the set of input values that are possible. So when you look at this in these linear pieces, now if it had been just a single line, any real number is possible for a single line because you can plug any input in, you can get an output, you can find an ordered pair to match any x value. With a piecewise function, you want to make sure that that's still true. So you can look at the first piece and say, okay, I can plug any x value in here that's less than negative 1. And I know I'll be able to get outputs for them, so there are no problem candidates here. There might be problems in other kinds, nonlinear functions like square root functions or some rational functions where there will be some things that are not in the domain. But for a linear function, they're generally pretty friendly. So I can plug absolutely any number into the function that's less than negative 1. Then I look down at the next piece and say, now I can plug in negative 1 itself and absolutely any number bigger than negative 1. That's kind of all numbers, right? Any number less than negative 1 and any number greater or equal to negative 1 is all the numbers. And so your domain is really going to be everything because anything will fit into one of those two categories. Sometimes piecewise functions will skip stuff. They'll say, use this piece if you're less than negative 1. And then use this piece if you're greater than 1. They might not tell you what to do between negative 1 and 1. So that would be a piecewise function who might have skipped some values, which would not have a domain of all real numbers, but this one does. Okay, now for the table. So in this table here, we want to plug negative 3 as an input into the function. And so when I plug it in for x, there are two places where it could go. And I have to look at the condition and say, does it satisfy the first condition? Negative 3 does. So I would plug negative 3 in for x here. It does not satisfy the second condition. Negative 3 is not greater than negative 1, so I cannot use the bottom function. So this one is going to be negative 3 plus 1. Negative 3 becomes positive 3, minus 1, I meant to say, minus 1. So 3 minus 1 is going to be 2. So this is going to be our 2 value right here. And then each of these values you will plug into the condition that it satisfies in this condition choice over here. So, for example, positive 1 satisfies the bottom condition. So 1 plus 1 is 2. So you have another 2 right there. You can get Desmos to help you with this, only if you happen to name the function two different things. So I could have it help me. We have it help us with the table a lot. I can have it help me with the table if I name these two different things because I can't have two rows or I can't have the function defined the same way when I'm going to go into these tables. But I could do it. And then I could have it plug in, say, negative 1. And now notice that negative 1, perfect. I don't know. I was thinking of something else. I was thinking momentarily before I got distracted that the first value on this chart wasn't negative 1, it was negative 3. So I could have plugged in negative 3 to get the first value right there. I'm going to go back and change that, but I can plug in any of these values, and what I'll see if I change that to negative 3 is that that's the 2 I was looking for because I plugged in the first value and it satisfies this condition, is that the other function is going to say undefined because you can't plug this value into both parts. You can only plug it to the part that it satisfies. So you'll get numbers out of the top half for values that satisfy the top half. You'll get numbers out of the bottom half, like we said, for 1 was the other example we talked about, for values that satisfy the bottom half. And so Desmos can help you get those values, or you can do them by hand, your choice, it doesn't matter. All right, looking at some of the other pieces of the 116 LC, sketch the graph. And so we can see the graph in Desmos. We were able to type in with two separate function names these two pieces using the curly bracket around the conclusion. So we saw that when I was screen sharing that a moment ago. That's the way you would type it in. You can name them both during the graph phase of it, but if you want to use the table, then you do have to give them different names because it would not be able to figure out which F you meant where if they're the same name. Okay. All right, so back over to learning check for a second to look at this shape. So that's just a verbal description in writing about what you think the shape looks like. No big deal there. And then the range. So the range is the outputs. We already talked about how the inputs are, and I can do the input piece more analytically because I can think about what type of X I plug in. I can't think quite as easily about what type of output I get out, but I can see them graphically. So if I go back to the picture right here, I can see, okay, outputs. So I can see that I get a lot of outputs that are up in this region but my function's not going down here, so I'm not getting this kind of output down here. So you're going to want to express the type of outputs that you're able to achieve, the ones that you do see, outputs that we do see, in either an interval or in an inequality, your choice. Make sure this one is not going to be everything, because there's definitely some outputs that are not achieved. Outputs are the y values, right? There's some y values that we don't achieve, and a lot of y values that we do achieve. Okay. So I hope that takes care of that piecewise function question. If you have some more questions, send them over, let me know.